Good day to all. My name is Sudarshan. I'm a research scholar doing my PhD under the guidance of Dr. G. Aruthamat sir at the School of Electrical Engineering, Weather Institute of Technology, BIT Weather. My work is basically focused on electric vehicle battery charging application. So I'm working on AC-DC converters, DC-DC accelerated converters for my battery charging application for EV specifically of higher and lower voltage batteries. As we electrical engineers know, our battery charging systems have converters which operate at multiple frequencies. We have high frequency components such as rectifiers and DC-DC converters, and low frequency components such as inverters, which operate at around 5 to 20 kilometers. So there are combinations of converters which are required for the charging system based on the requirement, and my work is on those things. So when I have to do the hardware of implementation of a prototype, by building a hardware script is of course a little difficult, but still it is possible. Most researchers, from what I have seen from my friends and other co-scholars, face error as in controller. How to build the controller, how to understand the different components of the controller, how each block of the controller works, what is the exact output that is required at each block, why is that output coming that way, and why not some other way. So when we talk about different other processors, from what I have seen, learned on 3-4 processors, I find that seeing block-wise outputs is very difficult in multi-processors, especially when we go for hardware implementation. If let's say I have built a closed-loop control and I want to see the output at the end of the PID controller when it is online. So that option is not always available, with different other processors. So that's when I got to know about WAVECT WCU300 from Interval, from my professor, and I learned that through the help of my professor and from application engineers of Interval, and I found that the controller is a very robust one where high frequency and low frequency pulses are possible. And the advantage that I saw was not only is the waveform of high quality, both at high and low frequencies with great sampling in the inbuilt sampling because of FVGA. At every point in my controller, it is possible to see the output, which poses a very big advantage for a researcher who's working on debugging of a controller. The reason is, before I have pulse output from my controller, I want to make sure that every point in my controller is working properly, such that the output is as expected, even when there is disturbance given to either load or source side. It could be any component. In such a scenario, I saw that with WAVECT WCU300, it is very easy to observe these waveforms, and it is customizable. We can view the waveforms on different platforms, like if it's digital waveforms, we can see on PWM ports or DIO ports. If it's a raw waveform, we can see through ADC, BACs. You can do all the conversions, see it on SCO, see it on their own WAVECT suite. So it gives very flexible option for projects, specifically research scholars and MTech and BTech students who are interested in doing their higher studies, and researchers and publishing papers, to make sure that our control can be debugged very easily with as robust response as possible and with the least amount of time taken for operation. Because we don't want to spend hours together to get one output just by changing one small parameter. We take half an hour to build this, and that is not really required for us. With WAVECT controller, I found that those issues are eliminated, and it is very helpful for me personally. I found that to debug my controller, get wonderful outputs from it for closed loop and open loop applications. So I will definitely recommend this controller for use by other research scholars. And I want to talk about one more thing, that is the support that I got from Interval engineers. Whenever I faced an error and I got back to them through their query system, it was addressed very instant. It did not take more than maybe a day. So that becomes a very important advantage, because as research scholars, we will be waiting so that we can get our outputs and get proper novel outputs. So when the support from their end is so good, it encourages us to do better and find more fine-tuning. So that's how I observe. So I definitely recommend WAVECT controller for application, for different converters, for controls. Thank you.